All right, get this. Ready to dive into some serious sci-fi vibes? Like fertilizer that just grows itself, powered by the wind.
Sounds pretty wild, huh?
Yeah, but we've got some sources here, a Stanford research paper, and this article from ISI Spectrum,
Yeah.
and they're laying out this tech that could be, well, revolutionary.
Yeah, no magic involved, though it might seem like it at first.
Yeah.
Researchers at Stanford
Yeah.
come up with this device. It can make ammonia, and you know that's a key thing in fertilizer, right?
Right, yeah.
And they're making it with just air and water vapor.
Okay, now you've got my attention, but I gotta say, I'm a little skeptical.
Sure.
How do they make ammonia from thin air? I thought you needed, like, these massive factories for that.
You're right. The old way of making ammonia takes a ton of energy, needs those high temperatures and all that pressure.
Uh-huh.
But this new thing, it works just at room temperature, normal air pressure,
Mm-hmm.
and it's just using wind power.
Okay, now I'm really curious. Break it down for me. How does this even work?
So picture this. You've got this super fine mesh, like microscopic almost, and it's coated with these special materials. They're called catalysts.
Wait, catalysts? What are those exactly?
Okay, so a catalyst, think of it like a matchmaker. It doesn't actually become part of the final product, but it helps bring those other molecules together
Oh, okay.
so they can react and make something new.
Gotcha.
In this case, it's helping the nitrogen and oxygen from the air react with water vapor, and boom, you get ammonia.
So the winds, like the power source, and these catalysts, they're like the facilitators of this whole chemical reaction.
Exactly. And then to collect the ammonia they've got going, they use this solution. It's got something called zeolite in it.
Zeolite.
Yeah, it's this porous mineral. It's got this structure that's really good at grabbing onto certain molecules, and in this case, it's grabbing the ammonia.
So it's like a little tiny wind-powered ammonia factory.
Pretty much.
This is blowing my mind a little bit. Did they actually, like, test this thing out, outside the lab?
They did. They took it out to 9 different spots around the San Francisco Bay Area, and they got some really promising results.
So it's not just, like, a theory. It works in the real world.
It does. Yeah. One thing they found was that the wind speed, it didn't really affect how much ammonia they got, but the humidity, that did play a part.
Wow. Okay, well, this is all very cool, but here's what I'm thinking.
Yeah.
Ammonia, it's not just for fertilizer.
Right.
It's also being looked at as a, like, green fuel source.
You're totally right, and that's a great point to bring up.
So could this thing, like, help us power cars or, I don't know, even whole cities someday?
Yeah, so ammonia, you can break it down. It's called cracking. And when you do that, you get hydrogen. And then you can use that in fuel cells or even regular combustion engines.
Hold on, back up a sec. Cracking.
Oh, yeah, it's basically just a chemical process. You're breaking down a molecule into smaller pieces. So in this case, cracking ammonia, it releases the hydrogen.
And then that hydrogen, that's what we can use as fuel. Wow, okay, so we could power cars, trucks, even cities, all with ammonia made from, like, this little wind-powered device.
It's a possibility. But let's not get too carried away just yet. There are still challenges, especially if we want to make enough of this stuff to, like, meet the world's demand.
Right, I imagine making enough ammonia to replace, like, all the fertilizer and fuel we use now, that would take a lot of scaling up.
For sure. We're talking about building the infrastructure, figuring out all the safety stuff, making sure there aren't any, like, environmental issues that pop up.
It's a big undertaking.
It is.
And that makes me think, if we want this to, benefit everyone, including those developing countries, how do we even make sure it's something that they can actually get and use?
That's a big one, for sure. And it's something we need to think about from the beginning. As this tech keeps developing,
Okay.
we need to find ways to make it affordable, to build, to get it where it needs to go, to train people how to use it.
This is a lot to take in, but it's pretty exciting stuff.
Yeah, no doubt.
I mean, we've talked about fertilizer, we've talked about fuel, even transportation, but are there other ways we could use this that we haven't even thought of yet?
Oh, absolutely. The possibilities are huge, and some of them might really surprise you. One thing that's really cool is, like, think about all those places that don't have reliable energy, like way out in remote areas or, when there's some kind of disaster.
Right.
This thing could really be a game changer for them.
Oh, yeah. I hadn't even thought about that. So they wouldn't need to, like, rely on those diesel generators or try to hook up to the grid.
Exactly.
Which can be super expensive or just not even possible in some places.
Yeah, they could just make their own power with wind and air.
That's amazing. And what about, like, I don't know, shipping? Could we power ships with this or even, like, airplanes?
Airplanes. Well, that one might be a little further out there.
Yeah.
But they are actually starting to try out ammonia-powered ships.
Really?
Yeah, and ammonia, it's way denser than hydrogen. So you can pack a lot more energy into a smaller space. which is like super important when you're talking about transportation.
So this could help us like get rid of all the fossil fuels in those industries, the ones that have always been like the biggest polluters.
Yeah, definitely. I mean, if we could do that, it'd be a huge step towards fighting climate change.
Absolutely. But with any new technology, we have to think about the good and the bad, right? Like, are there any risks with this thing?
Oh, yeah, for sure. I mean, one thing is ammonia, it can be toxic. So if there was like an accident and some of it got released, that could be a problem.
Right. We wouldn't want to solve one problem and just create a new one.
Exactly. And then there's the whole question of like access.
Yeah.
We don't want this to just be something that the rich countries get to use. It needs to be available to everyone.
You can't just make the gap between the rich and the poor even bigger.
Right. So it's not just about like the science, it's about ethics too.
For sure. We need to make sure that this benefits everyone, not just a select few.
It's going to take a lot of people working together to get this right. Scientists, policymakers, industry people, and the communities that will actually be using it.
It sounds like this is just the beginning of a much bigger conversation.
Oh, yeah, absolutely.
This has been really, like, eye-opening, you know? It's crazy to think that something so simple like pulling ammonia out of the air could have such a huge impact on the world.
Yeah, it really shows what humans can do when we put our minds to it.
But it also shows that we have to be careful. We have to think about the risks, the ethical side of things.
We can't just get caught up in the wow factor. We have to think about the long term, make sure this benefits everyone.
It's crazy to think we've only just scratched the surface here. Like, this whole thing has got me thinking, what else is out there? What other impossible stuff might we actually be able to do?
Right. It's like science fiction is becoming science fact.
Exactly. So we've talked about fertilizer and fuel and even like ships and planes. But what about like really big picture stuff? Could we use this to power, I don't know, spacecraft for like really long missions?
Whoa, now that's an interesting thought. If we can pull it out of the air here, why not on other planets?
Yeah.
It could totally change how we think about space exploration. We could make fuel and all kinds of stuff right there on the spot.
We wouldn't have to haul all that fuel up from Earth.
Exactly.
That would be, I mean, that's a game changer. But are there like any big roadblocks to actually doing that?
Well, I mean, there would be engineering challenges, of course, like each planet's different, right?
Right.
You'd have to adapt the tech to work on Mars
Mhm.
with that thin atmosphere, things like that.
But it's possible, like in theory.
Conceptually, yeah, totally.
That's incredible. This is why I love science. It just like changes how we see the world, you know?
For sure. And this ammonia breakthrough, it's just one example. There's so much happening right now in so many different fields.
It feels like we're on the edge of like a whole new era of technology.
It really does.
We're learning how to like tap into nature
Huh.
in ways we never even thought of before.
And this is why we need to keep investing in research and pushing the boundaries of what we know. Who knows what else is out there waiting to be discovered?
This whole deep dive has really got me feeling optimistic about the future. You know, it's like no matter how tough things get, we humans, we can figure things out.
I love that. It's so important to remember that amidst all the challenges, there's so much potential for positive change.
Absolutely. So, as we wrap up here, what would you say is like the main takeaway for our listeners?
I think it's a message of hope, you know? This discovery, it shows us that we can create a future that's sustainable, that's fair for everyone.
Mm-hmm.
It's like a call to action, to get behind scientific research, to be part of the conversation about how we use these new technologies to make the world a better place for all of us.
Couldn't have said it better myself. And on that note, it's time for us to sign off. But before we do, we want to leave you with one last thought. If we can pull ammonia from thin air, what else is possible? Keep that question in mind as you go about your day, and never stop exploring, never stop questioning, and never stop diving deep into the world around you.